Welcome back to my Porsche 911 restoration project. This week, I'm going to do the seam welding on the front of this chassis in the trunk area. And I want to know, does seam welding actually improve the structural integrity of the chassis? Does it increase the stiffness? So I'm going to be doing some before and after testing to determine, is the juice worth the squeeze? So stay tuned. Just a warning, this episode might get a little bit nerdy, but there's only one way to find out.
Garage time.
So I should probably start and explain what seam welding is. Seam welding is additional welding done on top of the factory spot welds. So resistance welds or factory spot welds are how this car was put together. And by adding weld bead on top of the existing factory beads or existing factory welds, that can increase the chassis stiffness. So this car is built with layers and layers of sheet metal and box sections. So as you increase the weld of those box sections, it should increase the stiffness of the car. The next question is, Tom, why do I care if the chassis is stronger? It's not going to break, and it's lasted 40 years. Why do I need to make it stronger? So my answer to that is that you want to increase the stiffness of the chassis so that the suspension can do the work. The more the chassis flexes and bends under dynamic driving conditions, the less accurate the suspension can be. So cars are aligned on alignment benches with lasers, or we have lots of modern tools today, but imagine laser aligned wheels in a garage where it's parked on a rack. That's great, but when you go out and drive the car, that alignment is very different. Things can bend and flex, especially on a race car when you put better suspension, you put stickier tires. These cars from the 70s especially flex a lot. So you want to try to eliminate that flex so that the suspension can do its job and the alignment can stay as ideal as possible as it's going through the paces, whether it's acceleration or cornering or braking. The way I'm going to measure this improvement is to try to lock the rear of the car down in a fixed way. So I put the rear, and by the way, I'm not going to be spending a ton of money and time on this. This is just kind of a quick, does it improve it, does it not improve it? I'm not going to go through a rigorous method of how to, measure the actual torsional stiffness. What I've done is I put some jack stands in the back, and you can see where I attached them. Normally I wouldn't put jack stands. I wouldn't recommend putting jack stands in this part of the car. But because there's no trans, no engine here, I think it's going to be fine. It's not going to damage anything. But it's one of those precarious places where the jack stands could slip. So if you're doing work to your car, I don't recommend putting the jack stands here. But there's a reason why I'm doing it, because I want the jack stands to be as wide as possible, because I'm going to be twisting the chassis at the front and I want the back to stay put. I want the back to be locked down as best as possible. And in the front, I've welded on a bar to the front suspension pan pickup points, the same pickup points I just installed when I redid all the suspension pan work. So this bar, I have some tubes here with bolts going through it into the factory holes. I have it extended to the passenger side of the car so I can actually push down on the car, and that's going to create a torque on the chassis. So if the back of the chassis remains fixed and the front is bending because I'm sitting on this bar, then I can measure how much it bends down and do some before and after testing. So if the chassis is indeed stronger with seam welds, it won't bend down as far. And I'm monitoring it with this indicator, dial indicator here. So it's got enough movement to where I should be able to see a difference. And I'm going to be doing this method probably again when I add some more parts here in the front trunk area. I'm going to be adding the weld in strut braces. I'm going to be putting the strut bar across, and then those diagonal braces across the front. So I want to see improvement, and I just thought this would be valuable for myself and hopefully for you guys to understand what these changes do to your car, and is it even worthwhile doing? Okay, I put a little mark here on this bar so I can always put the dial indicator in the same spot as I go through some testing. Okay, I don't know if you can see in the back, but all 4 wheels are off the ground. So we have no suspension components in play. The back is supported, like I mentioned earlier, by those jack stands. You can hardly see them there, they're yellow. And then I have the driver's side supported by this jack, and it's supported directly underneath this front suspension point. And then this side is unsupported. So I'm going to be putting weight on the end of this bar, and that is going to twist the chassis. So I'm gonna set up the cameras and show you what happens when we load up the chassis. Okay, so when I sit on this bar, it's hard to see. I can see the gauge moving, so I know that there's a lot of movement. But I'm sitting on the end of the bar, and I'm putting, I would say, 95% of my weight on the bar. Like, I'm not going to lift my feet up so I don't fall over, but I'm just putting as much weight as I can on the car. So when I lift off, the gauge goes back to where it was, and when I sit down, it deflects. So I'm going to do this 3 times and average the measurement, make sure that I pay attention to where I'm sitting on the bar. Basically, I got, my right hand on the end of the bar. I know it's kind of an awkward position, but this is all in the name of science, right? Looking straight ahead. Okay, that's 1. That's 2. That's 3. Okay, now just for completeness, I'm gonna move this camera to the rear tire, the driver's rear. So what I wanna determine, I don't think this is gonna happen, but when I put pressure on the front right, I wanna make sure that the back left is not lifting up. There's no engine, this car is pretty light right now. So I'll calculate how much torque I'm putting on the front, but it's a pretty good number because it's way out to the side of the car. So I want to make sure that the back left is not lifting. So I'm going to do the experiment again, not really recording the number, but just putting a camera on the back so I know as I sit on it, is it lifting or not. All right, I'm sitting on my car a couple times, just give it a little bounce. I can definitely feel this thing flexing. These cars, they're really not as strong as you might imagine. So when you're driving up like a driveway or something, especially like in a Targa, you can actually see the chassis flex a little bit. And I can feel it now just sitting out here on the end. Now this is abnormal because there's a long cheater bar on here, but all things bend, and I just want that to kind of sink in. Just because it's metal, just because it's a car, doesn't mean it won't bend. Okay, I'm gonna start cleaning out some of this wiring and hoses and things that are sort of in my way. These are the seams I'm gonna be working on, but before I start welding, I want to relax the car. So it's supported off axis on purpose so that I could do that test. But right now, because I want to do some welding, which could cause some permanent distortion, I want to make sure that this car is sitting on its tires as I do the welding. And I'm going to be moving around to try to, control the distortion, but distortion is very real when welding. So I don't want to lock it in a distorted state by leaving it supported the way it is. So I'm going to put it back on its tires and then just start cleaning this area out. This will be a future headache for sure. Okay, some of you will probably remember this car was abandoned in the Nevada desert, and when I got it, it didn't have a hood on it. So all the wiring, all the hoses, all that stuff is extremely sun damaged. And like for instance, this is like a piece of vinyl tubing and just snaps like super easy. The brake reservoir, all that stuff was just UV irradiated. I mean, it's just done. Okay, back to seam welding. That was a fun little diversion. But these are the seams that I'm talking about. So you can see the little dots, that's where the factory spot welded it. Here's where the factory, did put some seam welds in. Not sure why they didn't do it everywhere, but on this car, it's just, kind of sporadically in there. Remember from last week, this is my welding to put this strengthening top plate in. And I haven't done the passenger side yet, so I don't think that's gonna affect the measurement because this is just a local area. There is a seam right up here, which I'll probably do some seam welding on. And then down here, more welds. But before I can weld it, obviously I need to strip the paint off. Okay, I've really gone to town on this thing, done tons of welding. It's all done. It needs to be cleaned up and obviously prepared for paint, but there's welds in basically 5 different levels. There's 1, 2, 3, 4, and 5 at the top. All the corners are welded. There's a weld here along the back of the gas tank. And also here at the front of the gas tank, I think you can see that there's welds around the front. And then all the way back up into the corner on both sides. So I hope there's improvement. Now is the moment of truth. Let's check it out. Okay, here I am again, exact same place I was this morning, just sitting on this bar that is attached to those same front suspension points. I haven't even moved the bar. It's been here all day. The only difference now is the car is seam welded. The car is supported in exactly the same way. I have my camera here watching the dial indicator. It is in the exact same place because I marked the bar where I had the dial indicator last time. And the only thing that's different is I had lunch. So maybe it's like a 2 or 3 pound difference, but who cares? So let's turn the camera on and see what the results are. I'm gonna take 3 measurements just like last time. So I have my hand on the end of the bar and I am relaxing. So it's number 1. Relaxed, number 2. And no, number 3. And last time. It's 4. So I'm going to look at the video, find out what the numbers are, and determine if it made any difference. Okay, the results are in, and it's a little bigger than I expected. So here are the numbers. Right, so here are the numbers. The deflection in the first case was on average 0.130 inches, so a little over 1/8 of an inch deflection. And I will calculate how much the torque was in a minute. And then afterwards, the deflection went to 0.110 of an inch, so less than 1/8 of an inch. So the final case minus the initial case divided by the initial is a 15% decrease in deflection. So that is actually a little more than I expected. Not bad. Okay, these results are not super rigorous. The way I was putting weight on the bar is kind of inconsistent. The way that the car is supported is not 100% correct. I haven't gone through processes of leveling and doing a bunch of rigorous testing, but I think it's enough to say that the seam welding does make a difference. I didn't seam weld the entire car. I only seam welded from the dashboard forward. So the twisting that I'm measuring is the total car from the front suspension pickups to the rear torsion bar. So if I was to do more seam welding inside the cabin and underneath the car, the tunnel area and the longitudinal, the below the door sill area, if I was to do more, it could actually continue to increase the stiffness. But I just wanted to know, is it beneficial? And it seems like it is. Now I happen to know that that's also a 15% increase in the torsional rigidity. So I'm going to get a little bit nerdy. I'm going to do some calculations to try to find out what the torque was, what's the sort of angular displacement, and just kind of get nerdy. And I don't want to try to say that this is the torsional rigidity of the chassis, because it's not perfect, okay? The places where I'm measuring from. Okay, I've just worked out some math, and I'm trying to calculate the torsional rigidity of my setup. Now, don't take these results as the gospel of how to calculate torsional rigidity. This is not anywhere close to how you're supposed to do it. So here we go. Okay, here's a quick example of torsional rigidity. This is my, my trusty ruler, and it's clamped to the table. And torsional rigidity is a measure of how difficult it is to just twist this ruler. So you can see it just deforming as I twist it. The jack stands on the rear torsion bar are similar to this clamp. It kind of locks in the rear of the car. And then what I'm doing to the front is I'm twisting it. In this case, I took the front and I twisted it down in the passenger right. The passenger front, I twisted it down. The parameters that affect how difficult it is to twist this ruler or twist the car is its inherent strength, the strength of the material, the length of this particular piece of the ruler, which would be the length of the car. A limo would have less torsional rigidity than a Porsche, for instance. And then it's the structure of the car that really determines how difficult it is to twist. That's what I'm going to try to calculate. By me sitting on the car, I applied some torque to the chassis. So that torque is equal to, I said 95% of my weight, which happens to be, I'm 180 pounds. So it's 801 newtons times the distance that I was sitting out from the end of the car. That's a 1.55 meters. And so that's a torque that I applied to the chassis of 1,179 Newton meters. Now, the car deflected downward, and I measured that with the dial indicator, but I need to convert that into an angle. So the angle is the distance between the suspension points, was what I measured from. I measured from the passenger suspension point to the driver's suspension point. That was a distance in the first case, so the before case, of 130 thousandths of an inch. And yes, I'm converting units. This is in metric units, and then this is in standard units. And the reason why this is in English units is because the gauge I have is in English units. I prefer metric, but that's a different story. So this distance was 130 thousandths, and the distance between suspension centers is 26 inches. So you can use the tangent relationship to calculate the angle. The angle in the before case was 0.2865 degrees. The angle in the secondary case after I did the seam welding was 0.2424 degrees. Now to calculate the torsional rigidity, I'm just using this kind of linear relationship. You know, I could have done several more data points with different weights and different angles and stuff, but I just want to get a quick answer on this. The torsional rigidity is equal to this number here, which is a value of K, which is the torque that was applied to the chassis divided by its angle. Now, the torque I calculated from up here, 1179 divided by the angle at first, equals 4,117 Newton meters per degree. After I did the seam welding, it turns out to be 4,864 Newton meters per degree. So the percent change is the final minus the initial over the initial. I get a 18% increase in torsional rigidity. So there we go, 18% increase in torsional rigidity. This is a very rough estimate. Please guys, don't try to take these numbers and compare them to other cars. The way I measured it was kind of worst case on those front suspension points. I think the car is much stiffer than that. It's an 18% increase. I mean, I'm going to win 18% more races, right? This channel is all about building your dream car. Have I said that before? Thanks for watching the video, guys. I know this is a little different than the typical restoration video, but I was excited about it. I wanted to share the results. I think there's some value in putting numbers to these modifications. I think so often it is monkey see, monkey do, and whatever looks good, you know, like strut bars. They are obvious when you open the trunk and they look cool, right? So they look, oh, it's a race car because it has a strut bar on it. I am probably going to repeat this test after I put my strut bar on, and yeah, you know, I'm going to do it. I'll repeat the test and see if the torsional rigidity is going to change. I hope you appreciate it. If you did, please subscribe to the channel, and more videos like this to come, and I hope this generates at least some discussion down in the comments below. Take care, and we'll see you next week.